In this video, we're going to be calculating the yield of this product in the chemical equation. To do that, we have to set up conversion factors to calculate the limiting reactant of the equation. In the experiment, we started off with 15 grams of the first compound. To calculate the limiting reactant, we have to set up conversion factors by converting it to moles. In 1 mole of this compound, there are 74.14 grams. And then we have to multiply that by the chemical ratio of how many compounds does one compound yield. So all of these will be 1-to-1 ratios. Now you see that all of our units will cancel. And we are left with moles of the product. Now we're going to do the same process with the other two compounds. And we are left with 0.22 moles of the second compound. Now, as you can see, the first compound was the one that had the smallest mass. So that will be limiting our reaction to 0.2 moles of the product. So to figure out the yield, we have to multiply that by the atomic mass of the compound, which is 137.03 grams. And that will give us 27.72 grams of the product. Now, in our experiment, we measured out that we created 17.1 grams of the product, and theoretically we should have had 27.72 grams of the product. So to calculate our percent yield, which is the difference between our two yields, we do our experimental over our theoretical yield, and then multiply that by 100 to get our percentage, which was 61.7%. In the end, we're going to be left with excess of the other three compounds. So, since we had 0.20 moles of the first compound, that has to react with 0.22 moles of the second compound and 0.33 moles of the third compound. These second two will be left with excess. So what we do is we simply subtract to figure out how much excess we have of each compound. We can do this because in our equation the chemical ratios were 1 to 1. So now we're going to do that with our third compound. And you can tell that we are left with 0.02 grams of sodium bromide and 0.13 grams of the third compound.